Hi, everyone, and thank you for joining us. Today, we'll be talking about biometrics and the real challenges and attacks happening right now. We'll share what we've seen, tested, and learned from building identity verification that actually works in today's real world, otherwise known as the wild. My name is Andrey Patishman. I'm Executive VP of Identity Verification Solutions here at Regula. And today I'm joined by my colleague, Andrey Terekhin, Head of Product and the man behind our biometric tech stack. Together, we'll take you on a tour into what it really takes to build a robust biometric system, not just in theory, but in real-world conditions. Before we begin, a few housekeeping items. If there are any audio issues, please try dialing in using the numbers provided in your invitation. Also, feel free to submit your questions live in the chat during our presentation. We'll answer them in the Q&A session at the end, or our team will address them as we go. This webinar is being recorded, and we'll be sending out the link over the next few days. Let's start with this conversation, why this conversation is so urgent right now. We're seeing a fundamental shift in fraud. Digital identity fraud is no longer the work of professionals alone. There's been a 244% rise in amateur fraudsters just over the past year. And with generative AI tools now readily available, just about anyone with a phone can become a fraudster. At the same time, over 40% of all identity attacks are now AI assisted, making them cheaper, faster, and more scalable than ever before. Andrey?
Yeah, and that's at the same time, biometric adoption is up to 21% year over year, and it's moved from convenient to critical infrastructure. And why, can you ask? Because when it fails, the consequences are drastic. For example, OnlyFans. We got fined over 1 million pound of for what? For per age checks. And AI mechanism works because over 40% of frauds nowadays are now AI assisted. And that's very different threat model when we have observed even 2 years ago.
When we say biometrics, it's not just one thing. We're talking about a whole set of technologies from retina scans to fingerprints, voice, gait, and even behavioral patterns. But there's one modality that stands out when it comes to remote identity verification, and that's face. It's the most common, the most convenient, and unfortunately, the most targeted by fraudsters. So if the threats are growing, what are organizations doing to fight back? Well, across every industry, facial biometrics have become the #1 tool to counter fraud. We're talking about banks, fintech apps, telcos, airlines, even healthcare providers. They're all adopting facial biometric identity verification as a frontline defense. And it's not just for onboarding anymore, because facial biometrics are now critical for transaction confirmation, access control, and ongoing authentication. Now that we've seen how the threat landscape is evolving and why facial biometrics are becoming the go-to defense, it's time to dig deeper. To understand what truly makes a facial biometric verification system resilient, we need to answer 3 core questions. First, who's attacking us and how exactly are they doing it? Spoiler, it's not just professionals anymore. Second, which technologies actually deliver protection and which ones just look impressive on paper? And third, which is the most overlooked question, how do we verify that our systems will hold up under real attacks? Let's start with the first one. The truth is, today's fraud is no longer a job for pros. It became easier than ever to fake an identity thanks to widely available AI tools, smartphones, and online tutorials. Fraud has become commoditized. You don't need Photoshop. You don't need a big budget. You can fool systems with a $2 printout on nylon. But here's the twist. The easier it is to create, the harder it becomes to detect. Andrey, let's look at what it actually looks like in the wild.
Yeah, let's have a look. And on different example from different part of the spectrum. And as Andrey correctly said, we used to think that spoofing biometric required some resources, time, money, some special techniques or whatever. But situation has changed, and nowadays it's no longer true. And here on this slide, there is a great example. It's a nylon stocking with printed face on it, two bags, and that's it. No complicated 3D modeling, no silicone, but it works. And it's funny that it works against many systems. And another example is a real mobile app that swaps your face with someone else just in one click. People use this app just for fun, but Fraudster, they creative and they adopted this app for fraud. And what makes these attacks dangerous is that they don't look like attacks. But if system lacks proper resistance, they can slip right through. But let's move on and have a look at the another side of the spectrum. And here is you can see how low the bar can be. And here is the example of actual presentation attack, a very simple attack, printed masks. And they are literally attacks you can build at your own home with your own equipment. And that's why they are dangerous. And fraudsters keep on using them, keep on exploiting them, and they even try to make them more sophisticated, like an example on the right, where you can see a layered structure with printed structure, which is used to mimic 3D features of real face. And you can't skip these attacks, even though they are on a low level, because they are still in a game. And let's have a look on the other side of the spectrum, more sophisticated attacks. And here we can see AI. And when AI comes into the play, everything escalates very quick. And on the left side, you can see something like already classic deepfake attack. And this attack can be generated with even mobile app within a second. In the middle is morphing, when two faces blended together to full system that relies on static image comparison. That's essentially dangerous for document insurance. And on the right side, you can see the top-notch example. Something like a face avatar generated from a single photo that mimics real movement with all lighting condition and 3D features. And these aren't science fiction anymore. These are actual tools that Fraudster are already using. And the line between physical attacks, what you have seen on the previous two slides, and digital AI assisted like here one, is disappearing very fast.
Thanks, Andrey. Now that you've shown us the kinds of attacks that are happening right now, some simple, some surprisingly advanced. The natural next question is, what about the technology that's supposed to stop all this? Is it AI? Today, AI is everywhere. Almost every vendor says their system is AI powered or driven. But what does that really mean? Is it actually making systems safer or just giving us the illusion of security?
Yeah, that's a good question, because fortunately, AI can not only help Fraudster, but also those who tries to protect against them. But let's get clear, AI not a magic. It's a tool. And like a tool, it can be incredibly efficient when it used right. And what stands apart AI in biometric system is that ability to learn patterns. For example, it can create high-quality face embeddings that are more robust than traditional face features. And this powers anti-spoofing detecting if it's real or a mask or screen or deepfake, whatever. And then it combines with multi-model inputs like document data, liveness, different session behavior. AI becomes even stronger. And the real power of AI comes from scale and speed, because AI can instantly analyze millions of different signals from different sources. And no any human or even a team of humans could ever do such analysis. But with great power comes responsibility, and responsibility here is drawbacks of AI. First, that's overfitting. Because let's say if a model is trained on only perfect studio lighting and high quality samples, it won't survive in a while. No any chance. Second, it can learn wrong signals. We've seen models that make decisions based on some background, some glare, not the face itself. Third are blind spots. Because if you do not train on enough different samples, different cases with different conditions, well, the model just won't recognize these signals in the wild, and once again, won't survive. And finally, some kind of summary of all above. Overconfidence. Some model might report 99% quality, but it might mean almost nothing if you don't know what was behind, what data and processes. And Henry, would you mind to share a couple of interesting examples where these confidence can lead?
Thanks, Andrey. Those were some great insights. And here's the real danger, because it's not just that AI makes mistakes, it's that it does so with high confidence. What you see here are two different people, but the system gave a 98.5% match score. And when operators at banks or border offices see a score that high, they often stop thinking. This is what we mean by the overtrust in AI. In this case, not only did the AI fail, but it coerced us into falsely trusting it even more because of that high match score. So what you're seeing here are some real-world examples, not from test labs, but from actual deployments. So in the UK, there was a system that had a 92% false positive rate, but it kept being used. In the US, people were arrested, jailed, and even denied access based solely on AI match scores. This is not just a technical bug. It's a design flaw in how confidence and match rates are interpreted. And that's exactly what makes identity verification such a high-stakes environment. When the system says match, the consequences follow, even if they're wrong. So on paper, this looks like a technical flow: an identity check, match or no match, and a system decision. But in practice, this is where everything gets real, because what happens at this step has consequences. A match could mean access to services, approval for a transaction, entry through a border. But a no match might mean delays, errors, even losing access entirely. And that's the point. The fight isn't just against fraud, but it's against the illusion that our system is always right. So what happens when identity verification fails? Well, for individuals, that might mean being locked out of services, wrongly flagged, or even facing legal trouble. For systems, these failures stick. There's often no easy way to correct errors. A false result can become a permanent record. And for organizations, it's not just about bad press. It's about fraud getting in, lawsuits piling up, and customers losing trust. These failures don't come from bad intentions. They come from overconfidence in tools and processes that don't truly deliver. That's where the real fight begins, not just with fraudsters, but with assumptions. And this is exactly why we started our work in the Regula lab. Let's pause for a quick poll. With all the noise in the market, certifications, benchmarks, and bold claims, how can you actually tell if a biometric system is reliable? What signals would you look at as a buyer, a security professional, or even just a concerned user? Take a second to choose the option that feels most trustworthy to you, and then we'll continue. So, our poll is: how do you understand whether a biometric system is actually robust? Option 1, I look for real-world attack testing results. 2, I check if it's certified with IBETA, PAD, NIST. 3, I monitor performance in production. Or 4, I rely on vendor transparency and documentation. Or 5, I'm not sure. I assume vendors already handle it. Okay, we've got an educated audience that actually looks at systems that are certified and real-world testing attacks. That's very good to hear. There are 11% of those that rely on vendors already handling it, which is very interesting. Andrey,
Yeah,
over to you.
yeah. Thanks, guys, for sharing your thoughts. And it's really interesting that some of you choose to rely on vendor, because in the next hour session of our presentation, we talk about how we as a vendor, we as a Regula, handle this process, how we cook this in the right way. And in the Regula, we have a motto, which sounds like you can't trust what you do not test. And that's why we built the Regula lab. Not to just run benchmarks once and move on, but to treat testing as a core function like development or deployment, with which you are very familiar. And for us, QA is not something like the phase at the end of the roadmap, not at all. It's a kind of permanent loop, which sounds like test, break, fix, repeat, test, break, fix, repeat. And this is our mindset and a way how we make sure that our system works in a real world, not just on the release notes. So let's have a look at this loop. As I said, we don't just run tests, we build a continuous testing loop. And first step in this loop is that when we start with something like black box testing, when we have hundreds of thousands different samples already prepared, and we know some internal details of models, and we test some mainstream scenario, edge cases, but then we go beyond. And on the next step, our lab chases real-world trends. For example, I think you remember an alien stocking mask from the previous examples. It was just a market disruptor because for $2 you can get this printed mask with almost any photo on it, and it worked against many systems. And our lab tries to outperform such expensive spoofing gear. And the next is real feedback when we deliver our model to real production, to the wild. Because at this moment we stay in close touch with our customers just to collect this feedback from production production usage. And if something goes wrong, we almost immediately pull it back into testing and refining cycle. And finally, we submit everything for external validation, like a beta, which was mentioned. And we do this because, not because we have to, but because it's the only way to prove that we are not foolish ourselves with our intentions. And what is important as a summary is that this is not a checklist. It is a loop because data moves and attackers involved, and so should our testing. Let's move on and talk a little bit about lioness. Why lioness detection is so uniquely difficult to get it right? Why it's so hard to tackle this challenge? First, you need a huge amount of data. And we're literally talking about hundreds of thousands of samples, or better, millions. Second, you need not just genuine faces, but different attacks. And third, which maybe sounds obvious, diversity. So your system trained, if your system trained only on some type of face, lighting, behavior, whatever, it won't generalize. It will get biased. It will fail in the wild. It won't survive. So and this statement is true for both genuine faces and spoofing. So you need not only different skin tone or age or gender inside your database, but also different type of attacks. And here you shouldn't forget about first bullet, because all of these should be in scale, a scale of hundreds of thousands of different samples. And third, even if your data looks good and well prepared, models can mislead. They can pick up some shortcuts that don't hold the real world, and that's why we build feedback loops. And this gives us bridge to the final point, because we need human experts in this loop. Just because we can't automate all all steps. We need some ground truth. We need to review some edge cases just to help models learn the right things, not just showing off metrics. So let's summarize that Linus is not just a model, it's the whole system around it. And let's zoom a little bit and have a look at how we actually prepare our liveness, and not on a level like we put data in and we get the result back, but with real steps, because there is no magic here. It's just an engineering task, probably quite hard but feasible. And we start with a very basic but often overlooked question. What does liveness mean? And answer is not like it is moving. Not at all. We need to answer something more harder. Is it real? Is it genuine? And answer for this question provide us with basement for choosing right architecture, right type of neural networks, right segregation on different parts of task, and right organization of these neural networks inside these tasks. And only then data comes, because they should correspond to task. And here this key, hundreds of thousands different samples, both face and spoofing attempts of different types, and with variety of the real world, with device alignment, edge skin tone, gender, and eyes shape, and of course the icing of the cake is variety of different spoofing attempts. Something like you have already seen, but in reality there are a lot of them. And why? Our life and model will learn bias. So next, human experts step in. Why? Provide the ground truth, labeling data, do review of some edge cases, do cleanup of data, and they literally makes data usable and digestible for whole process. And then the model goes through training. And what is hilarious is the result. Result is that as soon as we got this model, what we do? We attack it. We attack it with different samples. We attack it with different techniques to validate it against known attack types and unknown to. And if we reveal weak spots, well, send it back, and this cycle repeats. And finally, only when we reach new higher level of quality, we add this model into our production products, and we deploy it. We send this to our customers. But that's not the end, because in our lab, we monitor performance, especially false acceptance and false rejects. And let's summarize. This is what we mean when we say it's not a magic. It's testable, it's repeatable, improvable. And that's actually the only way we know how to build trust in our biometric system. And let's have a look at our lab. Let's have excursion inside. This video from the lab, and everything you can see here is part of how we train and test our anti-spoofing system. As you can see, there are a lot of different equipment all around and some procedures. And what you are seeing here is just a fraction of what our laboratory works with. Fraction of what we can show you, can demonstrate here. And this is how the lab feeds back into this circle, into the training, fine-tuning, and making the product harder.
Thanks,
And let's
Andrey.
talk a little bit about results of this process. Henry?
Yeah, thanks, Andrey. That's some great insights into the inner workings of our biometrics lab. Now, this slide is not about marketing labels. It's about showing what our hard work has achieved, that we actually meet the highest standards in biometric security, and we can prove it. We rely on ISO IEC 30107-3 as our core benchmark. It's the international standard for anti-spoofing and sets a clear bar for what biometric systems must be able to handle in the real-world conditions. We achieved certification in both IBETA Level 1 and Level 2, presentation attack detection evaluations. These are independent, rigorous tests designed to simulate real attacks, not just lab conditions. And by real attacks, I mean exactly that. Printed faces, high-resolution videos, silicon masks, even deepfakes. These aren't theoretical threats. They're what we're actually testing against. We also took part in the NIST Face Analysis Technology Evaluation, which is one of the most respected benchmarks out there for biometric performance. It's a tough test, and we're very proud of how our system performed. We came out ranked #1 by NIST in age estimation accuracy for mean absolute error across various geographies, topping results for accuracy in Europe, East Africa, and East and South Asia. Not just amongst the few, but globally. And that's one of the hardest benchmarks to lead. And here's something worth remembering. Very few vendors actually meet the full set of these requirements. Even fewer can say they meet them consistently and are willing to show how. We do, as we believe that kind of openness builds real trust. Andrey, can you please wrap up with some key takeaways?
Yeah, let's wrap up what we have talking about today. As you said, and three key takeaways. And these takeaways are available for both sides. Those who build identity verification system and those who buy and implement them. And first is simple. Fraud is getting cheaper and is changing rapidly. So static defense just don't work any longer. And that means we as a vendor need to be highly adaptable and reactive to these changes. Second is that AI itself is not a guarantee, it's a tool. And as a tool, it can be powerful, but only if it's cooked in the right way. So blindly trusting the AI is how all the trust happens. And we have seen today where that leads. Third, do not evaluate tenders based on pitch list alone. What really matters is how resilient their system is to real-world attacks, how they react when something changes. And in other words, don't ask what the product does. Ask how it has been tested and how fast it can be adapted.
So why go this deep? Well, because the risks are huge. Just look at the potential fines for non-compliance. They are truly massive. And this does not take into account reputational risk, which could have far greater impact. Fraud is no longer rare. It's widespread, accessible, and increasingly creative. And when identity systems fail, it's not just a tech issue. It affects real people, real services, real trust. That's why customers today are asking harder, more technical questions, and vendors have to be ready with real answers. Before we wrap up, it's fair to ask, who are we to make all these claims about AI, fraud detection, and testing standards? Well, we're Regula. And we've been in the identity verification space for over 33 years. Long before AI became a buzzword, we were already working on document analysis, biometric verification, and border security. Our technologies are used in some of the most demanding environments in the world, including at over 80 border control checkpoints and global major banks. If there's a place where accuracy and reliability matter, we're probably there. We're also recognized in the Gartner Magic Quadrant for identity verification. But here's the part that we're really proud of. Out of the 9 vendors listed in the quadrant, 5 are actually our customers. That tells you a lot about how deeply we're embedded in this industry, not just as a competitor, but as an enabler of trusted solutions. Our biometric systems has passed both level 1 and level 2 evaluations by iBeta, and we're currently taking part in level 3 testing. That's not marketing, that's independent proof. We're also ranked #1 by NIST in age estimation accuracy globally, and that's one of the hardest benchmarks to lead. And finally, we make our own technology. We build it, test it, ship it, all in-house. That gives us full control over quality, speed of improvement, and pricing. We're one of the very few vendors who can offer cutting-edge performance at a reasonable cost, because we don't rely on third parties. And honestly, that matters, because identity verification isn't just business for us. It's our way of making the digital world safer and more fair for everyone. I hope that you found this webinar useful and interesting. Now we'll be happy to answer your questions. I can see there are a few here in the chat. let's see what you would like to know. Okay. Um, question from here. How do you test deep fakes? Andre, that's probably a good one for you.
Yeah, that's definitely a good one for me because answer quite simple. We create them. As you see in our lab inside, yep. We prepare different samples from different apps, different networks. We scan market and technical resources. What's the raw there? How can we generate them? So we prepare them, we put them into the circle of what I've talked about today, and we train our models. Hope that's clear. And I see the next question from Anonymous. Also, how fast can you respond to a new spoofing technique? That's a good question, which also relates to the previous one, because generally it depends on complexity of attack. But as soon as we reveal such spoofing technique, what we do, we attack this challenge with collecting data inside our lab to add to add level enough to train network. And generally, the cycle might be quite fast, couple of weeks.
All of the
Let's
questions seem to be for you. Here's another one.
Yeah, I see. Because next one looks amazing. Because it's also next step for the previous one and second one. Yeah.
Yeah. How
How do you
so I'll
ensure
read out the question
responsible?
for you. Yeah. How do
Yeah.
you ensure responsible AI and privacy compliance while using real world data for training your models?
And answer is that we use our lab to generate this data because we deliver on-prem technology. We can't touch data of our customers, not at all. We are not SaaS vendor, yeah. So that's challenge for us, but mainly this challenge tackle with our lab. And that's also reason why we have this. Inside our lab, we do our best to prepare data, real world data, as best as we can. So that's allow us to be aligned with different privacy compliance.
Okay, let's do this one. This is probably a good one. What happens if liveness fails? Can we set up fallback logic?
Definitely you can, because our technology return not just hardly coded so that you digest whatever we return. We return in some ways confidence level, in some way answer true or false. And you can use this answer to construct further logic to return feedback for your user or to decide what to do. So it's not just one stop and that's it. It's up to integration and it's up to business logic what you have on your side.
I think I'll take this question. It's a good one. Could governments introduce restrictions on the use of artificial intelligence in the future? Look, governments can certainly introduce restrictions on the use of AI, but I think the world and the technology has moved so far that irrespective of the restrictions, the use of AI will no longer be contained. And as much as governments want to contain it or do something with it, and I'm sure that there will be more stringent regulations, but I think the cat is out of the bag and AI will now be a mainstay as a technology in the use across many, many sectors. Another one for you, Andre. How can a company incorporate Regula?
Well, our product is shipped as a SDK and API. So to digest this, to put this inside your already existed infrastructure or new build from scratch infrastructure, you need just to get our product, install this, and use API in flow what's suitable for your business case. And you can easily test this API on our demo site, so without necessity even to install, just to understand how it works, both the Face SDK, biometric technology, and document reader technology which deals with documents.
So what Andre is saying, our technology is very modular, and many of our customers choose to use the entire stack, but you can also use the different components of the stack individually if you want to.
Definitely
Um,
correct.
Here's another good one. Is liveness foolproof? How can we always stay ahead of fraudsters? Unfortunately, in today's world, nothing is foolproof. You have got it's a constant race, and you have got to have other processes in place that assist you in making sure that you validate as much as you possibly can. And obviously, there are many different ways to do that, both by the technology, but more so through your business processes. Okay, this is also a very good one. What would be a good complementary identification method for your solution? Do you consider multi-factor compound verification schemes? Andre, do you want to tackle that one, or do you want me to tackle it?
I'm thinking how to answer because, as I already said, we are modular, we SDK, and we can be compound with some another factors, and we do not restrict on these levels, so that we do not insist that use only our biometric check, and that's it. No, it is possible to combine different uh, way to protect on integration level.
And my answer might be a little bit shallow on the technology side, but
Yeah, please
multi-factor
think.
compound verification, we definitely support multi-factor authentication and using a different variety of authentication techniques layered on top of each other. Because as you have more different varieties and different checks that you can do, the more robust your system becomes. Um, this is also an interesting question. What is the highest percentage of surety can one get? Will it ever be 100%? I guess the answer is we never want to say never, but it is highly unlikely that it will ever get to 100%. It's as we said, it's always a war between the bad guys and the good guys. So they're always using the latest technology, and then we use even better technology, and vice versa. So it's a constant war. Um, Andre, this one's for you. How often does iBeta certification test happen? And when you say that Regula has level 2 certification, which includes deepfake detection, does this include the more recent sophisticated ways of deepfake generation?
Good question, because iBeta doesn't regulate how often. And now I know only one regulation of European standard, which requires to pass through testing each 2 years. Uh, so here is answer just like by necessity. As soon as we approve technology, we're going to certificate one more time. But generally, we control on our side that we do not jump under the bar what we reach. So for us, it's quite evident that if one day we pass through iBeta, in the future we will stay at this level or above. Regarding deepfakes, that's a tricky moment because that's path test, and it means that they somehow present in camera different devices or printed or masks or whatever they have. So generally, even if deepfake generated, they present this on some screens. So that's mainly detection of presentation, whatever it is. So that's a tricky moment about iBeta certification.
Okay, there are quite a lot of questions. I'm very glad that there's so much interest, but in the interest of time, we'll probably start wrapping up. We will provide answers to every question that was asked in the chat. It will be responded to you, so don't worry. But in the interest of time, we will start wrapping up. So, on this note, I'd like to thank you all very much for joining us today. And if you have any further questions, ideas, or want to discuss how this applies to your particular use case, feel free to reach out. You can scan the QR code or just email us directly. all of our team will be more than happy to answer any particular specific requirements or ideas that you might have. So once again, thank you very much for joining us, and we hope that this webinar was of use to you, and we'll hopefully see you next time.